You're welcome once again. Today's tutorial is based on integration techniques, and one of the integration techniques that we want to consider is a simple use substitution. At least I've heard, or at least I know that most of you have heard of the use substitution. So not to waste much time, let's kick everything off. So first of all, let's consider these formulas. Formula 1, the integral of u prime of du equal to u r plus 1 over r plus 1 plus c. In this case, we assume that r is not equal to 1 or negative 1, sorry. The 2, we also have a formula like integral of u exponent u du, which is equal to exponent u plus c. And then the last one that I want to write here, it's integral of 1 over u du, which is equal to ln of u plus c. So basically, ln of u, since the ln does not accept the negative numbers, we assume that the ln, the u value should be greater than 0. So basically, based on these formulas, we can say that the variables u, which is this u, represent a more complicated expressions in terms of x. For instance, when we consider an integration or example, a function like maybe x power 9. Pardon me that my pen is not coming well. When we consider x power 9, right, we can carry out this integration using the power rule, the normal power rule, as we know already, which is x power 7 plus 1 over 7 plus 1 plus c, of which at the end of the day, we are going to get 1 over 8 x power 8 plus c. But what if you get an integral or integration which contains something like integral of 2x minus 3 or exponent 7? In this case, we can see that the integrand here is more or less complicated. So if you use the normal approach, are you going to do something like 2x minus 3 power 7 plus 1 over 7 plus 1 to get 2x minus 3 power 8 over 8? No, this is totally wrong. This is not how we do it. So if you want to confirm whether whatever you have done is correct, let's do the differentiation. When you do the differentiation to confirm whether you will get our integration back or this one back, we are going to get, when we differentiate whatever here, we are going to get 2 multiplied by 8, and then we are going to get 2x minus 3 all power 7. And here, don't forget it's over 8, so 8 will cancel it. Now we are going to get 2 exponent 2x minus 3 all power 7. So in this case, you can see that this function is not equal to this function. That means that the root that we pass here, it's incorrect. So based on this, we can apply a method that we call use substitution. Though I have a simple way that you can solve such questions. And let me teach you before I apply the U substitution. Oh no, let me proceed with the U substitution first. Then when you are comfortable with the U substitution, I'll come in to show you a shortcuts that you can use to solve such question without going through the U substitution. But for now, let's understand the U substitution, because some questions are there. You need to definitely apply the U substitution in order to be successful in whatever you are doing. So let's proceed. So since this one is not the same as this, it means that our method is incorrect. So in such case, we have to make whatever is inside the brackets to be represented by U. And therefore we can say that our U equal to 2x minus 3. So this representation, which is U equal to 2x minus 3, to replace this bracket here, it's what we call the U substitution. So basically, as I said earlier on, the U substitution, we can use it to represent some complex functions to make the integration easier and faster. So based on this, now we can write our function to be as integral of U power 7, because now our U equal to 2x minus 3. And don't remember, we need to get something, don't forget, we need to get something, either the U over there. But let's see something here. You can't just represent here by the U, because it doesn't come just like that. Remember that the dx is still there, it has not been eliminated, and we can eliminate it gradually. Now we say that, or we are saying that we should let U equal to 2x minus 3, and therefore we can find our du over dx is equal to what? 2. And remember that this question there was what? Dx, right? Over there. There's dx over there. And we need to substitute this dx. So how do we do it? Now we said that let U equal to 2x minus 3. And therefore we can say that du dx, the differential of this U, is equal to 2. Because we differentiated this function. So getting this, we can make the x the subject. So making the x the subject from this differentiation, we can do it like multiply through by dx. And I multiply here by dx, and I multiply here by dx. This dx will go for this dx, and now I'll have something like du equal to 2dx. So having du equal to 2dx, I can say that now my dx equal to du over 2. So having du over 2, now we can replace this dx from this part. And at the end of the day, we are going to get the integral of U power 7 du over 2. Now, this means that we can integrate this U with respect to U. So since 1 over 2 is a constant, we can bring it out from the integral sign. And therefore, we are going to get 1 over 2 out, multiplied by the integral of U power 7 du. Now we can go in peace to integrate whatever we have in front of the integral sign. So now you can apply your normal power rule, integration power rule, and therefore you are going to get 1 over 2, the integral of U power 7 plus 1 over 7 plus 1. And therefore you are going to get 1 over 2 and 1 over 2, then U power 8 over 8. And at the end of the day, we are going to get 1 over 16, because I multiply the 2 times 8. And then we have U power 8. But don't forget that in the initial stage, we said that let u equal to 2x minus 3. So if u equal to 2x minus 3, what do? We need to replace everything so that we can come back to the x domain. And therefore, we can see that our 1/16, and then the u is 2x minus 3, and then the power is 8. So now, this becomes our final answer. But don't forget that it's an indefinite integral, and therefore we need to introduce the constant plus c, which is the arbitrary constant of integration. So now I'll kind of leave it for you to check with by differentiating this to see whether you are on the right path or we are not on the right path. So in this case, you can differentiate this by using your shortcut integration techniques. As I explained earlier on, just take the power here, multiply by whatever is here. So it's going to be, and then differentiate here, also multiply by whatever here, and at the end of the day, just subtract whatever you want from it. So that's one of the shortcuts that we use for doing differentiation of such functions. And therefore, you can apply it to just check whether your answer is correct. So let's do it quickly so that we can end this tutorial and move on to the next tutorial. So doing this or applying a differentiation here, I'll have my power, which is 8, multiplied by the constant outside there, which is 1/16, multiplied by the differential of whatever is in the bracket, which is differential of 2x minus 3 is 2, and then I take the whole function, which is 2x minus 3, and then the power is going to be 8 minus 1. So at the end of the day, this 8 will go here, hot 2, and then this 2 will still go here, and at the end of the day, we are going to have 2x minus 3, and then the power will reduce by 1, which is 7, which is actually the same as the question which was provided for you over here. So this means that having an idea or understanding the simple use substitution will help you to solve some complex questions or problems whenever you encounter them. So thank you for watching, and see you in my next video.